So this is the slide where we had listed out all the devices under the category of finite automata. We started off our journey on automata theory by looking at a device or understanding the construction of a device called as finite automata. There are two kinds of finite automatas. One is referred to as finite automata with output, and the other one is referred to as finite automata without output. Currently, we are looking at finite automata without output. Okay. Once we begin understanding what is finite automata and how it is constructed, we started understanding a particular property of this device, and that particular property is being a deterministic device. Now, what do you mean by a deterministic device? In general English, once I am in a particular state of computation, that is in the finite automata terms, if I am in a particular state or a particular circle, okay, because the state is represented as that particular node of the graph. Then if I am in a particular node and I find a new input from the tape, okay, that new input from the tape is, say, suppose A, and I am in a state Qi. So suppose I am in a state called as Qi, and the input that I am looking at currently from my tape using the tape head is A. Okay, the deterministic device would know what will be the new state the device is going to go into. Okay, that is what the determinism means. So determinism means that there is only one way of moving from current state, current input to the next state. So this function delta, which defines this movement. So what does define the movement from one state to the other, Qi state to Qj state? The movement from Qi state of computation to Qj state of computation is determined using this function which is called as delta function. Okay, so this delta function that we have is taking two inputs. First input is current state, second input is current input symbol that the tape head is reading. So now based on these two inputs, if I can without any doubt say what will my next state be, and it is exactly one state, then we say that our device is deterministic, because we can determine the behavior of the device in such cases. Now, what makes me have Qi comma A map to exactly one Qj? It is the property of this delta function. The property that makes me have this relationship between Qi comma A tuple to Qj is referred to as delta, or the transition function being a total function. Okay. In terms of mechanical view of the system that we are modeling, the transition function, we refer to it as a table called as transition table, in which we have on one axis the states and other axis the input symbols. Okay, so here the columns are input symbols. So say suppose I have three columns, and then I may have, say, four states. So this is 1, this is 2, this is 3 and 4. So there are four states: state 1, state 2, state 3, state 4. Okay, and then I have input symbol 1, so I'm referring it to as A. Second, I'm referring it to as B, and third, I'm referring it to as C. So now there are four different states of computation and three different input symbols for this particular example transition table. So when I call this transition table a total function, whenever all these 9 into 4 cells, so 9 into 4, 3 into 4 cells, that is 12 cells, all these cells, they are occupied by exactly one state. So I have exactly one QJ occupying all these cells. All these 12 cells have 12 distinct states. Okay, so in terms of mechanically identifying whether a device is deterministic or not, आपको उसका ट्रांजिशन टेबल ड्रॉ करना है और ट्रांजिशन टेबल में देखना है कि हर एक सेल में एग्जैक्टली एक स्टेट है या नहीं. Okay, so this is the way to identify whether a finite automata without output is a deterministic finite automata. Okay, so the finite automata without output will be deterministic finite automata, or is it shorthanded as DFA or abbreviated as DFA when delta is total function. Delta is total function in English is meaning that for every pair of current state, current input, I have exactly one next state defined. I have exactly one next state defined. Okay, so that is the meaning of FA being deterministic FA. Now, what does it make a device non-deterministic? It's a very simple thing. Whenever my delta is not a total function, either I can miss a transition, that is I can have nothing mentioned in these cells, one of the cells or some of the cells I should say, or I may have more than one state to go to when a particular input is offered to me. So the device working, we saw it previously, but I'll just remind you how this device is working since we are into a new week. This is how the input is presented to the user. So whatever is the input string, I engrave that input string into a tape like device. Okay, so this is where I will be giving my input. So say suppose my input is 1 0 1 1. Suppose this is my input 1 0 1 1. Okay, and this will be the epsilon, or I should write it myself like this. Epsilon means end of the string. Okay, so this is how the device is presented with the input. This is called as the input tape. Okay, should use this is called as input tape for my device. Okay, then I have the device itself as a box, and this device has a table to which it refers to whenever it wants to find out the transition. So this table is referred to as the transition table. Okay, so I'll just put it in nicely. This is my transition table. Then I have inside this a smaller box which stores the current state. I should say QI. Okay, so this is the box that stores the current state. Then I have another box which stores the current input. Okay, so this is my input. Okay, there is a tape head. Sorry, there is a tape head, and tape head has a movement, and the movement that the tape head has is one cell to the right. So it at a time can move one cell to the right. So this particular thing arrow is a movement of the tape head, which is one cell right at a time. So at a time the tape head can move one cell right. Okay, I hope this is understandable now. Now what I can do as a device is, as I read this, so this is a read head by the way. So this is, I should write the name of it as well. So this is the, so this is read head. A read head means it is trying to read something. Read things from where? It is reading things from the tape and getting that stored in this particular variable input. So 1 will come first time, then I move the head one place to the right, so 0 will come, then 1 will come, then 1 will come. Fine. Now these two things, they are combined together, and I do a thing called as, sorry, draw it nicely. एक बार ड्रॉ कर चुका हूँ कैसे, तो भी ये थोड़ा नाइसली ड्रॉ करने की कोशिश करता हूँ. I am in a better position to draw. So trying to draw it. Okay, so I'm doing what? I'm doing a lookup. This operation that we are defining right now is a lookup operation. आपने डिक्शनरी सुना होगा. डिक्शनरी में क्या करते हो, आप कीवर्ड्स लेते हो एंड कीवर्ड से लुकअप करते हो. लुकअप से आपको कुछ आंसर मिलता है, एंड दैट आंसर एक्चुअली is taken back and stored over here. So what is the answer? The answer to the lookup is next state. So what I'm looking up, the lookup that I do is actually current state comma current input. So I do a lookup for current state, current input into the table which is referred to as the transition table. Okay, so this is how my device operates. So the first step that the device takes is to read a symbol from the read head. As I read the symbol from the read head, second step that I do is I do the lookup. Okay. Third is I update the next state. So this is an update. Okay, please understand that this what I am bringing is update. So here the operation that I am performing is update. What I am updating? I am updating this variable which is stored inside this box, current state. So current state gets updated. Okay, and the fourth operation that I do is the movement of one cell to the right. So this fourth is the movement that I am doing. Okay, so these are the four operations in a loop the device is performing. Ultimately, when this particular thing moves to this particular location, the device operation stops. This is when the device operation stops. Device stops operating. As I reach this particular line or this particular tape head location, the device stops operating. Now the next input I can keep it over here. This is an infinite tape and my device could keep doing the operations. Okay. Realization इसका कैसे होगा पता नहीं है, but this is how this device is constructed. This is the basis for device. The mathematical definition. So this was the organization of my DFA. This is my organization of generally an FA. I should not say DFA, I should say FA. Okay. Now FA without output का ये organization हो गया. ऐसे वो काम करता है. अगर FA डिटर्मिनिस्टिक है तो ये जो अपडेट आएगा उसमें सिर्फ एक स्टेट मुझे मिलेगा. अगर FA NF है, नॉन डिटर्मिनिस्टिक फाइनाइट ऑटोमेटा है, तो ये अपडेट एक तो मिसिंग रहेगा या ये अपडेट में मल्टीपल स्टेट्स आएंगे. तो आई हैव अ चॉइस ऑफ स्टेट्स हियर इन द अपडेट, either to update this current state with one or the other thing. So my device is now in a fix of choosing from multiple options. और ये जो fix है, choosing from multiple options or having no option at all, is referred to as non-deterministic behavior.